Welcome back, manual readers. Ready to unlock some knowledge and unofficially learn something new? Let's begin. Tired of paywalls just to talk to an AI? Paying for image or video creation? Generating your own AI music? What if I told you you could have your own personal AI running right here on your Windows machine? It sounds complex, but today's manual is the blueprint to make it simple. We're going to install a powerful open source tool called OpenWebUI that gives you a premium chat interface for any local AI model you want to run, including the powerful new GPT-OSS from OpenAI, your private chat GPT. Let's get this system upgrade started. I use this exact blueprint for all my own AI projects, from scripting to coding, and it's been the single biggest cheat code for getting things done without the subscription fees. This is the real-world instruction set, not just a theory. Our blueprint today is the complete end-to-end instruction set. A lot of guides will ignore the critical configuration that makes the difference between a fun experiment and a frustrating dead end. We'll run a pre-flight check, build the foundation, install the accelerator, launch the interface, and finally, fuel it with its first AI model. Before we install anything, we need to run a quick diagnostic. This entire system relies on a feature called virtualization. Therefore, we have to make sure it's enabled on your PC. But don't worry, checking is easy. Open your task manager, go to the Performance tab, and click on CPU. Look down here on the right side. You should see Virtualization enabled. If it says disabled, you'll need to restart your computer and enable it in your PC's BIOS settings. A quick search for how to enable virtualization and BIOS for your specific computer brand will give you the exact steps. Do not proceed until this says enabled. With our pre-flight check complete, we can build our foundation. We want to run powerful AI tools often developed for Linux. Therefore, we need to run Linux inside Windows. But we don't want the hassle of a separate computer. That's where WSL, the Windows subsystem for Linux, comes in. A quick pro tip, run a Windows update before you start. This can prevent a lot of common installation issues. Now, open your Windows terminal or PowerShell as an administrator. This is a critical step. You're going to type in one single command to install WSL and the Ubuntu operating system. WSL-install-d Ubuntu. Press enter. This will take a few minutes. Once it's done, you'll need to do a full system reboot to complete the installation. Don't skip this step. After your computer reboots and you create your Linux username and password, we have one more crucial configuration to make. By default, WSL is very conservative with your computer's resources. But AI models are hungry for memory. Therefore, we need to create a configuration file to tell WSL it can use more of your PC's power. Open File Explorer, and in the address bar, type %userprofile% and hit enter. In this folder, you need to create a new text file. Right-click, select New, then Text Document, and name it exactly .wslconfig. Make sure it doesn't end in .txt. Now, open that file and paste in the configuration you see on screen. You should adjust these numbers based on your system. As a rule of thumb, set memory to about half of your total system RAM and processors to half of your available CPU cores. Save the file. To apply these settings, open Terminal and run WSL-shutdown. The next time WSL starts, it will use your new, more powerful configuration. Now, a critical note on this memory setting. For AI, the most important memory is your graphics card's VRAM. When you run a model, it first tries to load into that super fast VRAM. The memory setting we just configured in this file acts as the overflow bucket. Therefore, if you have a GPU with 8 GB of VRAM, you should set the WSL memory to at least 8 GB, preferably more. But understand that if a model is too big for your VRAM, it will spill over into this slower system RAM, and performance will be impacted. Matching the model size to your VRAM is the real cheat code for speed. We're really just scratching the surface of what you can do with WSL. There's a whole world of advanced configurations, from running graphical Linux apps to fine-tuning network and file system performance. If you'd like a complete power user's manual for WSL, let us know in the comments, and we'll build that blueprint next. We now have a powerful Linux environment ready to go. Therefore, we could start installing our AI software piece by piece directly into it. But that can get messy. The modern solution is containerization, and the king of containers is Docker. The best part? Docker Desktop for Windows integrates perfectly with WSL. Go to the official Docker website and download Docker Desktop for Windows. Run the installer, making sure the Use WSL2 based engine option is checked. Once Docker Desktop is installed and running, we need to perform one more check. Open the Docker Desktop application, click the gear icon for settings, Go to Resources and then WSL Integration. Make sure that integration with your Ubuntu distribution is turned on. It usually is by default, but if you run into problems later, this is the first place to debug. Alright, before we launch our UI, we need to install the final engine component, the GPU acceleration stack. Getting this wrong is the #1 reason setups like this fail, but the real manual makes it simple. First, and this is the most important instruction in this entire video, you must only install the standard NVIDIA driver on your Windows host. Do not, under any circumstances, try to install a Linux driver inside your Ubuntu terminal. The magic of WSL is that the Windows driver itself securely passes the GPU through to Linux. With that out of the way, the second step is to give Docker access to that pass-through. We do that by installing the NVIDIA Container Toolkit inside Ubuntu. Open your Ubuntu terminal and run the commands you see on screen one by one. This will add NVIDIA's software repository and install the toolkit. After that finishes, the final command is the most important. You must restart the Docker service to make it aware of the new GPU toolkit. Run sudo systemctl restart docker. Now, our entire foundation is complete and correctly accelerated. Alright, manual readers, we have our foundation, engine, and accelerator. Therefore, launching our AI interface is now incredibly simple. We're going to use the final, definitive Docker run command that combines everything we've built. The command you see on screen does a few key things. It uses --network equals host to directly share the network, which is the simplest and most reliable way to connect to Llama. It uses --GPUs, all to give the container access to our NVIDIA stack. And it specifies the :CUDA version of the OpenWebUI image, which is purpose-built for GPU acceleration. Okay, run that command in your terminal. Once it's done, open your browser to localhost :8080. Note that because we're using host networking, the port is 8080, not 3000. Create your user and you'll see the interface. And just like that, you have a professional-grade hub for local AI. This blueprint gets text-based AI fully operational. But we also mentioned images and video, right? For that, we need an entirely different, node-based engine like Comfy UI. It's a much more complex system, but it lets you build incredible workflows for AI art and animation. It's a perfect candidate for its own unofficial manual. So if that's a chapter you want to see, sound off below. Now we have this beautiful interface, but it's just an empty shell. It needs an AI model. Therefore, we will install Llama, an amazing tool that makes running models easy. Open a new Ubuntu terminal. Now, run the command on screen to install Llama. Once Llama is installed, we can pull our first model. We'll use Llama 3 from Meta. It's powerful and a great starting point for most machines. In your terminal, type Llama run Llama 3. The first time you run this, it will download the model. Be patient. Once it's done, you'll see a message that says send a message. Now for the main event we promised in the intro. In the same terminal, let's download OpenAI's model. Type Llama run GPT-OSS :20b. A quick heads up, this GPT-OSS model is a heavyweight. It's over 11 gigabytes to download and requires a lot of RAM to run smoothly, likely 16 gigabytes dedicated just to WSL. So this one is for those of you with powerful machines. Be patient with the download. Once it's done, you can type /by in the terminal to exit the model prompt. Now, this is just a couple of models. The real power of Llama is its library. You can run models specifically trained for coding, smaller models, or even learn to manage huge models like GPT-OSS efficiently. If a full guide to mastering Llama and its library is something you need, you know what to do. Tell us in the comments. Now, we connect the two. Go back to your OpenWebUI in the browser. You're already logged in, so just select a model from the drop-down menu at the top of the screen. Because we used the Ollama_base_URL flag in our Docker command, it's already connected. You should see both Llama 3 and GPT-OSS available to choose from. You've done it. Now for a pro tip from the manual. Running this on localhost is great, but what if you want to access your personal AI from anywhere? A tool called Cloudflare Tunnel allows you to create a secure, private link from the internet directly to this application, without exposing your home IP address. And the best part? All the tools we use today, including a basic Cloudflare tunnel, are completely free. You get to run your own AI, and you can add a layer of enterprise-grade network security. Setting it up is an entire blueprint of its own, so we're building a dedicated manual for that, coming up soon. So there you have it. We ran a pre-flight check, installed and configured the WSL foundation, set up the Docker engine, installed the NVIDIA Accelerator stack, launched the OpenWebUI container, and fueled it with live AI models using Ollama. You now have the keys to your own private, fully operational AI kingdom. If you're ready to keep turning the pages of the manual with us, hit that subscribe button. For our next chapter, we want your input. Tell us in the comments what part of life you wish came with a manual, and we might just build that blueprint next. Thanks for joining the experiment.